بسم الله الرحمن الرحيم والصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. Okay, so today we're going to have an exciting lecture, and in the previous lectures we have talked about sensors, and in today's lecture we will talk about actuators. Okay, so sensors are devices that collect information from the environment, that you can collect them through a microcontroller, okay, process them, and then either store them or take a decision. Or we can read also the sensors to actuate or to make a certain action using actuators. So one of the types of actuators are motors, which are devices that are able to rotate, transform an electrical energy into a mechanical energy, and they can perform different type of functions depending on the type of motors. So just to get you motivated with the stuff, this is a small robot, very simple robot, but is based on two motors, two DC motors connected from here. And we can control them using Arduino. But looking at this board, and so probably I can switch to the next slide so everybody can see, this is the same board over here. So what do you see apart from the Arduino? So these are the two motors, okay? And you have here the Arduino, and you have different type of connections, and you can see that there is another device here. And today we will present how we can control Arduino or control the motors using an Arduino, and why we need an intermediate device to be able to do the control. So in the previous lectures we have already connected any sensing device directly to the Arduino board. But here we're going to have something in the middle, and I'm going to explain the reason of this. So let me show you. I'm going to make this robot move through a very simple application. Let me just check it here. I need to connect gamepad. It's connected. Look, now this is a very simple, this is the Arduino application, and here we will connect to this robot through a Bluetooth device. If you can see the blue color, this is the device, it's a Bluetooth, and then we can move forward. Okay, there is an issue with this one, okay. There is a friction, and I can rotate. So when we rotate, we're going to stop one motor and activate the other. We can rotate in the other side also, or also move backward. Okay. So in this lecture, you will learn how you'll be able to send control command to the DC motors and control a robot similar to this one. Okay. So what is an actuator? An actuator, it converts an electrical signal into a physical action. And this is something that we need in the Internet of Things, because IoT is not only sensing the information, but also taking actions whenever it is appropriate. And we will use motors, different type of motors, to take proper action. So IoT involves monitoring and controlling the physical environment. Like, for example, if you want to turn a fan on and off based on the temperature. Imagine that you have fans, and if the temperature goes high, you would like to rotate the fan. So we can use motors in this kind of situation, or if you want to move a robotic arm. Now, for example, to move a ground robot similar to this one, we have used DC motors, and there are other type of motors to move robotic arm, and which we call the servo motor. So different type of motors, DC, servo, steppers, are available to control different type of objects. And the main focus is that electric motor for rotation and also linear motion. So these are the different type of motors. We have DC motors similar to those that I have introduced in the robotic platform. And these motors they do continuous motion. They just rotate continuously. There is no calculation of angles. They rotate at a certain speed. And we use them in applications like fan control. And the speed will depend on the voltage that we will provide to the motor, and they can rotate in different directions, clockwise or counterclockwise, depending on the polarity. We have stepper motors. Okay, these offer precise and incremental motions. هذا اللي نستعملهم في 3D printers. If you have already observed the 3D printers, okay, it requires very precise motion control to be able to replicate the same object or the same design that you would like to print in 3D. So these are ideal for application that requires accuracy, like in robotics or 3D printing. And we have servo motors, which also have position control, and they use a feedback control mechanism to control the angle. For example, in a robotic arm, I would like to control the angle of a joint, okay, and the angle can go from 0 to 180 degrees. So I can send a message to tell the servo motor at which angle it has to stop. So it's going to rotate and control a certain angle. And for this, we need a feedback control, because I need to move and read the current position to stop at the correct angle. And this is common in robotics, like RC applications and also robotic arms. So why do we need motors? We need to have physical interaction with the environment, okay? So to move and rotate components in response to sensor and remote commands. We need to do automation, okay? For example, enable tasks like opening doors, rotating security cameras, or driving wheels on a robot. And this applies from hobbyist robot to even large and industrial machines. And we can connect them through Wi-Fi or through Ethernet to control them remotely. So let's start by the DC motor fundamentals. As already introduced, it's a motor that runs on a direct current. So we're going to provide a voltage. And this voltage is going to induce a resistance into, and it will create an electromagnetic field that will make the DC motor rotate. There are different types, like brushless or brushed motors. We're not going to go into those details. But at the end, we're going to have a mechanical response to the direct current that will be provided as an input to the DC motor. It's cost effective, so you can buy DC motors usually at low cost. Of course, if you want to buy an industrial grade motors, like for example those that we use on drones, the cost is going to be much more expensive. So depending on the characteristic of the motor, the cost is going to dramatically vary, but usually they can be afforded at cost-effective solutions. And DC motor, usually they come with different technical specifications. So when you buy a DC motor, you need to know what is the input voltage that is required. So some motors can work at 6 volts, 12 volts, 24 volts, 48 volts, depending on the thrust, depending on the speed that will be applied to this motor. And also the current, okay? The current, which says how many milliamperes. So some of the motors, they can work at 2 amperes. Some of the motors, they may require even to 40 amperes. For example, the motors that we use on drones, they can draw up to 20, 30, and 40 amperes, depending on how big is the motor and how strong is the thrust that has to be generated by that motor. And we have also RPM, which is rotation per minute, which is another characteristic of the DC motors. Now, imagine that you have a DC motor and you want just to control it with Arduino. So the first thing that you may think about it, you take the motor and you will connect it to one of these GPIO inputs in the Arduino. But why this is not possible? Why we cannot connect a DC motor directly to either an Arduino board or a Raspberry Pi? Okay, let me just make it easier. What is the voltage that is provided by an Arduino or a Raspberry Pi? 5 volts, or it can be 3.3 volts. And now going back here, the technical specification. So the motors, they may require to have 6, 12, maybe 24, maybe 48 volts. So now if the Arduino provides just 5 volts, what happens? We don't have sufficient voltage or current to make this motor rotate. So all these embedded devices, they cannot control the motor directly, so we need to have something in between. So we need to have a driver, and this driver will try to provide the necessary voltage for the DC motor to rotate, okay? For example, 12 ampere, 12 volts, or 2 amperes, and so on. And there is another thing. We want also to rotate the motor into 2 directions, either clockwise or counterclockwise. Okay, doing that directly, we cannot have reverse the polarity because the motor will have only two inputs. So the solution here, we're going to use a motor driver that we call the H bridge. So pay attention, because at the end you're going to have review questions at the end of the lecture. So to summarize, theoretically, it could be possible to make a direct connection, but in practice, this is not possible because of the voltage requirement of the motor and also the polarity that we need to change to make the motor rotate in either direction. It's not enough voltage and not enough current to make the motor rotate. And I put you here the link of a very nice video from where I took these pictures. I really recommend, if you want to take more information, to see the whole video in the link below. And this is the solution now. And if you remember, this is the same solution that we have in this robotic platform. You can see an Arduino. You can see the H bridge, which is the motor driver. And here we have one motor. But here, how many motors we have? 2. We have 2. OK. So this H bridge, it allows to control 2 motors. It's a dual H bridge, which is basically the same as we have here in the picture. So what is the solution now? The H bridge will have an input power. OK, so we will have an external power that will provide the required 12 volt or 24 volt, depending on the characteristic of the H bridge. And this is the ground, which is common for all. And also it has the ability to provide you in the output as 5 volt. So we can use this 5 volt to power the Arduino board. It can be used to power the Arduino board if we don't want to power it from the external sources. So having one battery connected here to the input is going to provide 12 volt. It will be converted to 5. This 5 could be used to provide the power to the Arduino board. And here we have 2 pins. These pins will be used to send control commands from the Arduino to the motor. Okay? These are 2 pins that will allow to control the motor speed or the motor rotation. And I will show you later on in the coding how can we switch high and low these 2 pins to rotate either in clockwise or in counterclockwise. We have another pin, which is also very important, okay, that will be connected to the Arduino, and through which we will provide an input to control the speed of the motor. So we want to control 2 things, the speed and the rotation. The speed is controlled by what we call the enable pin, and the direction is controlled by 2 pins that we also connect to the Arduino board. And this is the objective of a motor driver, is to be able to control the speed and the rotation of the motor. OK. And look, from the 12 volt that we get here, we can also have the output to directly connect to the motor. So we'll provide it the required voltage. And this voltage will be tuned, okay, based on the speed that we will provide through the enabled pin. Does it make sense? Any questions? Okay, so to summarize, an H-bridge is a circuit that allows a DC motor to spin in both directions by controlling the polarity of the voltage applied to it. So polarity, it means in which direction we want to make the motor move. It consists of 4 switches, which I'm going to explain now, that are arranged in an H shape. This is why we call it an H-bridge, because it has 4 switches that are arranged in the H shape. And how it works, so it's based on transistors, PNP and NPN transistors. Don't worry about these terminologies. But at the end, we're going to do the switches in a way to control the orientation of the motors or the direction of the motors. So let's make it simple. This is the circuit of an H-bridge, which has 4 transistors, S1, S2, S3, and this is S4. And we will control S1 and S3 together, and S2 and S4 together. They will have almost always the same state. So in the beginning, when all the switches are off, is there any current that goes to the motor? So the motor is stopping. I'm not going to provide any voltage. Okay, there is no voltage, so everything is stopped. Now the second state, putting S1 and S3 on, S4 and S2 off. So what will happen? I have the VCC and I have the ground. So the current is going to spin into this direction, and this will make the motor rotate into the clockwise. واضح؟ لأنه حركة الكرنت تأتي من هذا الطريق. Okay, this is how it's going to flow. The motor is going to flow. Now, if we do the opposite, we have off and on. So the motor is going to rotate in the counterclockwise. Okay, so if S1, S2 is on, S3 is on, it's clockwise. And if it is the opposite, it's counterclockwise. Now, what happens if I put everything to on? So if we put everything to on, we're going to have a short circuit, and this will lead to damaging the motor. And this is why it's important that you have high quality bridges, because there is a need to be a time between switching one device off and the other one on. If, for example, the time is not sufficient, you could be in situations such that you will have a short circuit, and this could lead to damaging the motor. Okay, so the way how it is implemented, there are 2 techniques. Like the technique that we've already presented is called, it's based on transistors, PNP transistors and NPN transistors, which are the bipolar junction transistor. They are very limited because they lose energy with the heat, and this will make the circuit less efficient. طبعا إذا كان حرارة ترتفع في أي جهاز الافشنسي دائما تكون أقل، ولذلك كثير من الأجهزة في الصيف تشوفوا أنه it really downgrade in terms of performance. It has slow switching. الآن مثلا لما باش تحب تغير S1 S3 من on للoff والأخرى بالعكس, it will take some time. So you don't have real-time control about the motor speed, especially in time-critical applications. It requires more power, okay, and also extra current to stay on, and this wastes energy. Now, another technique is called the MOSFET, which is just a more advanced type of transistors. It's the metal oxide semiconductor field effect transistor. It's just a terminology, but it is just another technique that is more sophisticated, that consumes less power. Okay, it has better heat efficiency, better motor control speed, and works easily with microcontroller. You don't need big cooling to make it work. And this table makes the differences between both, between the classical transistors and the MOSFET. So for the control here, you need to have a constant current, and here you need only the voltage. The speed, it's a slow switching, whereas there it's fast switching. For the power loss, here it wastes power with the heat, okay, and here it has better loss efficiency, low power loss and better efficiency. Okay, so now we are going to talk about the specification of this H bridge, which is exactly the same that we have here in this robot. Okay, this is called the L298N, 298N. It's available in the market. You can buy it. It's cost efficient. Okay, it doesn't cost more than $3, يعني 10 ريال في الأخير. And it's good for hobbyist project. Of course, it's not an industrial grade, but it can perform very well for hobbyist project. It's used in competition of robotics to control the robots and perform different regulation tasks. So what is good about this H bridge is that it allows to control two motors at the same time. وذيك علاش نستعملوه في الروبوتكس. يعني الروبوتس, this is called a differential drive robots. Differential drive يعني يعتمد على two motors, two wheels to move in any direction, either straight or rotate. ما هو نفس السيارة. السيارة يعتبر Ackerman steering. So it's different type of steering. This one, it's a differential drive. It's one of the easiest controllers for driving robots. Okay, very simple. If I want to move straight forward, so I need to send the same velocity or the same speed to the right motor and the left motor. إذا كان يشتغلوا بنفس القوة الروبوت يتحرك إلى الأمام. طبعا clockwise يمشي أمام و counter clockwise it will go backward. Now if I want to rotate, for example, I want to rotate in the right direction, in the clockwise, in the right direction, I will send a smaller speed to the right motor and the higher speed to the left motor. في هذه الحالة يصبح يدور يمين. إذا ناقص يولي يدور يسار. So this is how we can control the motion of the robot by applying different type of speeds to the left motor and the right motor. Okay, and this is what we implement here in the controller of the Arduino on how to control the speed, whether we want to move straight forward or we want to move or we want to rotate. And also what is the speed that I want the robot to move with, which is based on this particular pin, which is called the enable pin. Look now, everything is duplicated because we will control two robots. We have the input. We provide the input voltage, whether it is 12 or a different voltage. This is the ground, and this will provide a 5-volt input. And now, these three pins will control the motor A, the first motor. And these three pins will control the motor B. So this is what we call in1, in2, and ENA. So this is related. What is the ENA? To control what? The speed. So ENA, it controls the speed. In1, in2, it controls the direction. Because we have always linear velocity and angular velocity. So the angular velocity, it means if I want to move, rotate left and right, I will switch, for example, in high, in one high, into low. And if I want to do the opposite direction, I will make this in one low and this high. And this one will control how fast the robot has to move. The same thing, it's for motor B. We have in 3, in 4. And this one will control the speed of the motor B. And this is the output that will go to motor number 1, which is the 12 volt that we will send, or the regulated voltage. And this out 3 and out 4 will go to the motor number 2. And this is a 5 volt voltage regulator. So it will maintain a constant voltage, okay, without too much variations. Does it make sense? So this comes with a specification. It can accept an input voltage 4.5 volt to 46 volts. So it can work even on heavy motors. 46 فولت هذا من الموتورز بتاع الدرونز حتى الفيرتيكال تيك اوف اند لاندنج اللي يوصلوا حتى ل 20 كيلو. So it can operate at this voltage, but usually it's not good to work at the thresholds. Okay. The motor current, it can go from 2 amperes until 3 amperes. The overload, it has an overload protection. Okay, and we use PWM to control the speed. It's not a continuous voltage. You remember that PWM, we can define the duty cycle, and it can be controlled at 10 kilohertz up to 40 kilohertz. And this is a summary. Okay, so the L298N, it's a popular motor driver module that controls DC motors and stepper motors. It has 2 H bridges, forward and reverse motion. Okay, it can control 2 motors and can work easily with Arduino, Raspberry Pi, and other microcontroller like ESP32 or others. So you can use this H bridge to control 2 motors at the same time if you want to support high voltages and currents like 35 volts and 2 ampere per motor. And it has a built-in sink heat sink. شفتوا هذا الآن الأسود هذا مشغول لامتصاص الحرارة. هذا مهم جدا. اوكي، فهذا فيه ميتال من الداخل يمتص الحرارة حتى ما تأثر على البرفورمانس of the circuit. Okay, this is what we call the heat sink for better cooling. And it has simple connection with easy to use pins. So how it works, as already mentioned, we have in1 and in2 is to control the first motor, in3 and in4 to control the second motor, and we have PWM. Okay, enable A and enable B is to control the motor speed, either for the first motor or for the second motor. But it has limitation. It wastes power as a heat. It's not very efficient for advanced projects and need extra heat dissipation for high power motors. Okay, now let's go to Arduino. This is the connection. There is probably a little bit of differences in terms of the pins. Okay, so we have the input voltage, okay, that we will provide to the Arduino. We have here, we will provide 5 volts because these motors work just with 5 volts. And this is the ground. And this is the 5 volt that we will provide to the Arduino. And look, now we have this output will go to the first motor. Now, let me show you. This is the first motor. It will take the output from the H bridge, from this pin, from these 2 pins. Okay, these 2. واحد يمشي المحرك الأول، والثاني يمشي المحرك the second one. Okay, so this is how we do the connection. And what is the role of these 4 pins? These 4 pins, what is their role? To control what? The rotation, the direction. Okay, clockwise or counterclockwise. So this is a sample Arduino code where we can explain the connection. So here in this code, I will control only 1 motor. So let's assume that we connect the enable A to the pin number 9, and this is used to control the motor speed. We have in1 and in2. This is related for the direction of the motor, direction control pin 1 and direction control pin 2. So all these pins will be set in the output mode because they will always send signals, and you will use digital write. So they are digital pins. Now, if I want to rotate clockwise, okay, and don't confuse between the rotation. So in this case, clockwise, it means in1 high and in2 low, using digital write. And I'm going to send the full speed. So we work from values between 0 and 255. A full speed is equal to 255. So this will make the motor rotate clockwise in full speed for 2 seconds. If I want to stop, I will put input 1 and input 2 both too low. Okay, in this case, the motor will stop because I'm not going to send any signal. There is no control. And if I want to rotate it counterclockwise, so I will just flip between in1 to low and in2 to high. And I can, for example, if I set it to 128, in this case, it will rotate at half speed altogether. And this is to stop. Okay, any question? So look now, if you want to rotate at full speed, you can make analog write EN A to 55. If you want to rotate at half speed, you can make it 128. If you want just to stop the motors, put it to 0. Now, if I want to rotate at fourth speed, what I should put? 64. Good. Okay. So any question? So now another type of motor is called the servo motor. And the servo motor, it doesn't work in the same way as the DC because it will control the angle. So usually the servo motor هو اللي نستعملوه في الروبوتيك ارم. شفتوا الروبوتيك ارم بعض الاحيان نحب نفتح الذراع على درجة معينة أو نغلق الذراع على درجة معينة. So in this case we need to have a motor that is able to control the correct angle. And this angle they go between 0 and 180 degrees. In most hobbies Servos. طبعا في اللي يعطيك حتى 360 degrees. So it works also with the PWM, a pulse width between 1 millisecond and 2 milliseconds to define the angle. It works with voltages between 4.85 to 6 volt, standard for hobby servos. And also there is the torque. كم من كيلو يستطيع يحمل. Okay, so the torque, this is one of the characteristics of the servo motors. ما نكونش نعمل servo motor صغير مثلا ذراع روبوت مش يحمل شيء ثقيل جدا. كل موتور عنده سبيسيفيكيشن معينه تعتمد على الفولتج وتعتمد على الكرنت وتعتمد على التورك that it can provide. الرافعات مثلا يستعملوا servo motors that we can control either manually, okay, with a very high torque and also much powerful energy and voltage. السيرفو موتور it is composed of a DC motor, okay, it's a small motor for rotation, but also it has a gearbox مثل جير السيارة حتى يستطيع حساب الانجل. الجير مقسم, okay, this is for torque amplification, and the potentiometer for measuring the output of the shaft position, and with this it can control the desired angle. And we have a control circuit. For example, now I am at the angle 60, I want to move to the angle 90. This control circuit is going to count, okay, the motion until at the end it will reach the desired angle and will ask the system to stop at that particular position. And this is a simple Arduino code on how we can do it. Okay, so we define, it's already built in Arduino. You include the library servo.h and you define the pin. Okay, so here we create a servo object and you define a pin number. Of course, it has to be the same pin where this motor is connected. It's connected to the signal pin. And we use my servo.attach servo pin. So in this case, these servo motors, this library or this object is going to connect to the pin number 9. And from there, I can try to control. The control is very simple. If I want to move the servo motor to the angle 0, you just need to send the value 0. If you want to move to the angle 90, you just make my servo.write 90. And you can move to the angle 180 in the same way. So it's pretty much simple. And this can be used, for example, you can, we will have some hands-on activities to control with the Arduino like an opening gate مثل مواقف السيارات. هذوما غالبا نستعملوا فيهم سيرفو موتورز. إذا مثلا جت السيارة ممكن نستعمل مثلا ليزر. إذا السيارة وصلت إلى الموقف الليزر يكتشف أنه الديستنس اتغيرت and then we can send a control command to the servo motor to open the gate at a certain angle. this is one possible application where we can combine a sensor with an actuator for a full IoT application. The last type of motor is the stepper motor, which is a motor that rotates in discrete steps. Okay, so each step is 1.8 degree per step, and this makes it at 200 steps in full revolution. يعني 360 درجة يقوم 200 steps. It will rotate 200 steps in 360 degrees, which make 1.8 degree per step. And it doesn't have a feedback control. It's an open loop control here, and typically works with 1 ampere to 2 ampere per phase for small stepper motors. And it is used for 3D printers, CNC machines, camera sliders, and different other applications. There are 2 types of stepper motors, the unipolar and the bipolar. And the main difference is at the number of wires that is used to connect this motor and to control them. So the first one doesn't require an H-bridge, but the bipolar, it requires an H-bridge or specialized driver to reverse the current in each coil. These are just the specification of the driver of the H-bridge that can be used with a stepper motor, and we already talked about them. Okay, so what are the coils in the stepper motors? In the stepper motors, there are 2 electromagnetic coils, okay, and you can think about them as like 2 hands that will help you to achieve, okay, what the certain angle that you want to move. These coils create a magnetic field that makes the motor move step by step when powered into a specific order, okay, and usually we will connect the coil A to the output 1 and output 2 of the H-bridge, and coil B will be connected to output 3 and output 4 to the same bridge. So this bridge, it has 2 outputs, and it can connect 2 coils, and these coils are like 2 hands, as already mentioned, pulling the motor rotor into a specific direction. And this is a sample Arduino code on how we can do it. Okay, so first of all, we define a constant. So we include the library stepper.h, and we define the steps per revolution, and this may depend from one stepper motor to another. So let's assume that we have 200 steps by revolution, which makes 1.8 step per 1.8 degree per step. We initialize the stepper object, okay, and set speed to 60, and this means 60 rotation per minute. Okay, you can assign different type of rotations depending on how you would like to control the speed. Okay, this is 1 revolution forward. You can provide the number of steps you want to rotate, which you provided here, and you can also do it in the background direction by putting a minus over here. That's pretty much it for today. So we have completed the lecture about IoT actuators, and we talked about 3 types of devices, or 4 types of devices. The DC motor, the need for an H-bridge as a motor controller for Arduino devices. We talked about the servo motors and their applications, and finally about the stepper motors. Do you have any question? Okay, thank you very much, and now you can open ExamGPT.